You can actually score a significant amount if you just pay attention and do a little bit of the work at home as well. All right. When Ryan turns 25, he decides to start his retirement plan. He'll start a small investment account, and so $10 per week at 4% for 5 years. So how about I just show you the answer on that one? I feel like it's safe to do so. So we know that it's compounded monthly. So I always, when I fill it in on paper, I start at the bottom. When you enter it on your calculator, you decide whatever you want to do, right? So I start with the monthly compounding. We're making weekly payments. There are payments, so these two won't necessarily match. So I would say, I'll walk you through the marks in a bit. They're $10 payments. This has to be negative, right? Because you're giving them to the bank. This would be positive because it's coming back to you when it's time to take it out at maturity. Nothing at the start, 4%. And so this isn't just 5 years, it's 5 times whatever is in PY. So this is actually 260 weeks will have been considered in this calculation, right? And so your final amount is 26.64. Sorry about that. So 2 marks if you show me all of these entries and you have the correct answer with the units there. Yeah. I did the same thing. I got slightly different. 2888.5. Everything is exactly the same? I'm curious to see what are other folks getting. Are we getting this or are you getting a different answer? You got this? Nods. Some of you are like, no, I didn't get that, right? That's okay. But this is what you're supposed to get. I'm fairly confident that that is the case. But you know what? I do make mistakes. As you know, right? As you know, I make mistakes. 260, 4%, 0, -10, 52. It could be, you know what? I have a feeling that when you typed in 52 here, it turned that into a 52. Could that have been? Yeah, I get that. So if this is 52, you get 2877. Is that what you have? 2877? 2888. Oh, interesting. Yeah, I got it right. So if all the values are correct, but the final answer is wrong, half off only, something went wrong when you typed it in. That's why you want to show everything like this, okay? If you made 2 mistakes, like if I see that you made 2 mistakes anywhere, I would go -1 right away, right? So 2 things are off, I would take off 1 right away. Maybe even more. I feel like the province would have said if 1 mistake, half, like it's just 1 out of 2. And if there's more than 1 mistake, they actually gave 0. I'm going to double check that. Anyway, so 2 marks there. How much interest was earned? So Robert, if you got a different answer, then this will be different, I'm assuming. So that's fine. Like we would then just honor it. So it's 276.64 regardless of how you did it, using the formula or using the function there. Then this money is now, right, the 2876 is being inserted here. So Robert, you would have a different value here, okay? It's negative because I'm putting it in the, right, I'm investing it, putting it in the bank. So I start with the CI being 4 because that's the compounding periods. There are no payments. You're just letting it sit there, so these match. See? This is what I'm solving for, right? And so this gets inserted from A into here. Whatever you got in A, if that shows up here, I would honor it, right? Interest and then this is 35 years, right? Because it's 65 minus 30. That's 35 years that have gone by. Not a whole lot for retirement, if you ask me. Maybe 2 months worth of living. So 35 times 4, that's 140. So this would be 140 quarters. I don't know if that, we don't use that term very often, right? But that's what that would be. Quarter of years, right? So 8,626 and 20 cents there for that one. And so what do you got, Robert? 9? Oh, 62. So it's not a whole lot. It's not. It's very close. Yeah. Okay. You're doing okay? I don't know, right? Usually it's 2 marks if you start from scratch. If you do another one right beside it that goes off of this one, it's 1. I feel like in this particular scenario, I think that moving forward, I'll probably give you some marks for this. But let's just keep it at 2 here. Then it's estimating the doubling time for an investment. So we go 72 divided by the rate, right? You want time, not doubling rate. You want the doubling time. So we go 72 divided by 315, and that's approximately 22.86 years that it will take for your investment to double. So this page is worth 2, and 1 is 3, and another 3. This is 6. This page is worth 6. Now the back side. Okay, so you want $7,500 in the future to have enough for your tuition. This is compounded monthly, and it does say, right, it says compounded monthly right there, and it says how much you have to put away each month. So it happens to match anyways. You want this much, which will come to you in the future. Therefore, this is going to be a negative, but we don't worry about it when it's your final answer that you're solving, as long as you have the 284 with a dollar sign. And 3 years go by times PY, so we're considering 36 months. I wish I would have asked you, like, what's the balance after a year, right? So be careful. Yeah. Yeah, as long as a dollar sign is there. So remember this, I can't ask everything because I think it's going to be too much, but it could have asked you, what's the balance after 1 year, right? That would actually transfer to balance after 12 months, right? It's 1 times 12. And you could have figured that out, like how much you have in the account, how much interest will you have earned after 2 years? Sum of interest 1 to 24, right? And you figure out the interest there. So the sum of interest has to be used if you're figuring out within the investment. If you want total, you can use formula or the function, okay? Question 3. Block that last one there. So let's do one at a time here. So you're comparing, there's a very intentional, I was very intentional with the time, right? So it takes 15 years under the first investment. So I start with the bottom, it's compounded quarterly. I want to make monthly, right? How much you need to save each month. That means it's 12 payments a year. You want the $1 million. Over 15 years, that times 12, that'd be 180 months you would have to contribute, and interest would be calculated. Actually, interest is calculated 4 times a year, but that's happening behind in the background. So all in, this is how much you'd have to put away every month to make that happen, right? So that's quite a bit, but you get 2 marks if all of that is right. If you made 1 mistake, take off -1. If you made more than 1 mistake, nothing for you, okay? But make sure you learn. Then I go to the second one, and really everything stays the same, like the future value, the payments per year, the compounding. Did I miss something here? It's shorter than this one. Maybe just bigger font. But your payment is 1,018 here because it's 30 years times 12. This has to be 360 here. So this is how much you pay. It's a lot less, right? This is why I want you to save when you're young. It takes you less money to get to that goal versus you waiting until you're older and then you start. This is why. And the main reason is what I wrote down here, but I will explain it one more way yet. So you get 2 marks for this, 1 mark for that, okay? Just so you understand that. Explain why. So given that one has more time to reach the goal, there will be more interest earned in addition to the contribution, right? Additionally, this is the kicker here. Compound interest causes exponential growth. That is the main reason that is the case. Yeah. It's 1,001. You have the exact same as me. Anybody else getting 1,001 before I? Oh, oh. I have a few hands up, so I better check. Uh, this is 12. That's 4. Yeah, you're right. Thank you. $1. Gotta take everything you can get, right? Even though, yeah.
To get the market on soon, did you like the main thing you have to talk about is the exponential stuff?
The exponential growth is mainly what I'm looking for. But if you're not sure, let me decide. Just put a question mark. Add it up still. Like if you don't want to give yourself a mark for that one, right? Add it up and just say, please check 3C. But I will tell you, I feel like my key is going to get really messy. But this is like if you compare linear, if it's linear growth, right? To go from this amount to this amount, it's going to take the same amount of time to go from here to here, right? Like the time that goes by is the same. Whereas if it's exponential, at first it's very similar to linear, but then it actually goes very fast. So to get to here, right, to a certain amount, it grows faster. So it's actually less time later on than here, right? So it's the exponential growth that makes the difference, right? That is one of the main kickers. But I think you also need to kind of consider, right? You have more time, you're going to earn more interest. That's going to help you as well. So the combination of more time and the exponential growth, that combination is what makes it so powerful. And I don't know if you noticed, right? It's less than a third, right? Less than a third to get the same goal. That means that the rest is earned in interest. So putting away 1,000 a month, it's quite challenging, but it's possible, right? Okay, but most of you will have more time anyways, right? Like if you start at 20, right, till you're 60, that's 40 years, right? So you could probably get away with less, probably $800, $700 a month, and you get there. Um, soon, guys, soon we're gonna switch it up where you reach your goal. Now you retire. Now you want to start withdrawing money, correct? This is going to be depleted. But the nice thing is, as this is sitting in your account, you're still earning interest, but you're only withdrawing a little bit at a time, right? So it's kind of like it's slowing down uh, the depletion, basically. So we're going to talk about that yet as well. Anyway, so we have a total out of 12, not 10. Okay. Make sure your name and last name is on there, and then get your books out. We're going to go, I'm going to just stop this here. There. So let's go through A, B, and C, right? So let's answer A first. Leonard is saving for retirement, sorry. He's 45 right now and hopes to have 500,000 when he retires. If Leonard saves the same amount every month, so that's monthly payments, 5% compounded monthly, then to retire at 60, right? Wants to retire at 60. How much would he have to deposit each month to reach his goal? How much interest would have been earned, right, by the time he retires? Lots of stuff happening there. So when you have something like that, just leave the interest for now. Don't worry about that. Let's focus on everything else. So we go N, I, PV, PMT, future value, PY, CY. Would you be able to fill this in right now? You should be able to do most of it. It's compounded monthly. We're trying to save a certain amount each month. We want $500,000 at the end. We want to know what the payment is. This question is very explicit about that, so no questions there. Present value, well, we have nothing. They have to mention that you start with an amount, right? Interest is 5, and the age between 45 and 60, I'm going to figure that out on the side here. How about I do that right here? Time is 60 minus 45. So only 15 years. That's just it. A lot of people find out too late. Oh, I have to have my stash, right? They start thinking about it when they're already well advanced in age. And that's too bad, right? I feel like we don't talk about retirement because we are like, why would young people worry about retirement, right? But it's actually important. So 15 years times 12. Okay, we figure that out. And then just grab your TVM solver. That's 180. Everything the same, so 500,000, 12 and 12. Let's figure out our payment. You need that filled in to be able to use sum of interest if you want to use it. And so in this case, right, I need to make payments, or Leonard needs to make payments of 1,863. That's a lot of money. I don't know about you, but to have that much money available, that's quite the stretch, right? Interest earned, we can just go future value, right? Minus the present value minus payments times the amount that you're putting in every month. And this will sometimes vary slightly because the TVM solver uses more than 2 decimals for the payment, but that's okay. As long as you show me the work, right? Oops. Let's quit that. Just make sure you show me the work along the way. So there's 163 to 86.60. That's not bad, right? Earning 163,000 in interest? That's pretty good. That's a 5% interest rate. That's not that hard to find. Okay. You can keep buying 5-year GICs every 5 years, right? The only problem with GICs, you can't make monthly contributions. GIC is like, I have 100,000, I want to put in 100,000 and lock it in for 5 years, right? But once you accumulate a certain amount, take some of that and put it into a GIC and just let it sit there for 5 years, right? There we go. Okay, so we got that figured out, right? Let's do the rate of return just for fun. Interesting way of defining fun, right? There's nothing fun about this. Interest rate, rate of return is really 163, like the interest you've earned. That's really what it is, divided by the principal. And what's your principal in this particular case? Can you spot it in any previous calculations? Right? You made 180 payments of this much, right? So this is actually the principal. Let me highlight that. Let me go a step further. All of this is just an aside, right? So I'm going to take that divided by 336, 713.4, and I know I'm getting a negative. Don't worry about that, because I subtracted backwards, right? So that's 48.49% rate of return. I don't know if we want to box this in, right? That's our rate of return. This is our interest here. We figured everything out. B. It says if Leonard decides to wait to retire at age 65, but keeps the same savings goal, how much less would he have to save each month compared to A? Right? So let's do that. NI, PV, PMT. I need to watch my time here. Anyway, so the time is now 65 minus 45, right? So we've got 20 years. We've got extra 5 years of time. And we multiply that by 12 because everything else stays the same. Compounding, payments, the goal is still the same. We are going to figure out the payment. We have nothing to start, and it's a 5% interest rate. So that's 240 here. So let's do that, 240. Everything else is the same. So I'm just going to go alpha, solve for payment, and that's 1216.45 if you round it. 1216.45. How much less? Payments will be, we're going to figure that out just on the side here. 1216.45 minus 1870.63, right? 654.18. 654.18 per month less, or will be lower by that much. which is significant, right? Waiting, if your goal, if you just say, you know what, instead of 60, I'm going to retire at 65, adding the extra 5 years saves you 654 a month, right? Which means that you still want the same goal, but you're putting in less, which means that who has to make up the difference? Like, it's the bank with the interest, right? And that is making up that difference. What do you want to do? Formula? Let's go with this, 500,000 minus 0, because there's no present value, minus 240 payments of 1216.45. We're not going to do the rate, or should we do the rate of return maybe to show? Are you excited, guys, to do finance? You're speechless. I get it. I get it. 208,052. Interest. Rate of return. 208.52, the interest you've earned, and you've put in right now 291,948. Compare that to the top. How much did you put in the previous example? It's highlighted, 336,000, right? Here you only put in 291 of your own money. What's that? Not a dollars. So we got to go times. It's 71.26%. It gave you a higher rate of return because less of your money had to be put in to make that goal, to make your end goal a reality. And I'm just gonna use a different highlighter. How's that? Okay. C. Can we do this before we pack? I know you're like anxious to get out of here. I don't think this will be a stretch for you to understand this. So you're basically saying if everything else stays the same, you make monthly withdrawals, your future value will be 0, right? When is it depleted? When it's 0. In the present, you have basically negative 500,000, right? You've reached that goal of 500,000. You would like to withdraw how much? 1,500 a month. It's positive, right? Because it's coming to you. This is coming to you. You still earn the 5%. We're going to figure out how long that will take to withdraw, to deplete our account. So we put negative 500,000. Our payment will be 1,500 coming to us, 0 there. Everything else stays the same. Alpha, enter. What happened there? The money, the 1,500 is coming to you. No, it has to be positive. Let me see if I put a 0 there and then do alpha solve. No. I'm